Hi there, my name is Carol Henry, and I, along with my partner Ariella Silver, will be giving a short recap on what we accomplished this quarter to advance our project, Regulation Devices. At a high level, the challenge for regulation devices is to improve SIG meetings through in-the-moment regulation while maintaining flow. But in order to understand what this challenge really is, you need to know what SIG meetings, regulation, and flow all mean. Starting off with SIG meetings, these weekly meetings are between mentors and mentees of the same SIG or special interest group. Special interest groups are made of undergraduate mentees and a grad student mentor who are all working on projects in a similar domain. SIG meetings aim to address the current most important thing for a mentee's project, so it can look very different. Normally, SIGs focus on the mentee's research plans for the next week or two, but occasionally it might be used as an opportunity to get feedback on a time-sensitive deliverable, such as a URG proposal. At other times, it may concern metacognitive or emotional blockers that are preventing the mentee from getting their research done. While these three are the most common SIGs, with the planning by far being the most common type, other SIG styles could occur if there are other important things to address. Now, that covers the SIG part of our challenge. Next is the regulation part. When we say regulation, we mean the ability to control and direct one's behavior so that they can meet certain standards, achieve certain goals, or reach certain ideals. Regulation is a process. One must identify a goal they want to achieve, monitor themselves in relation to that goal, and then determine if their current state is their goal state, or if that they need to change their behavior to reach that goal. We want this regulation to happen in the moment during SIG instead of after the fact, so that changes can be made during the current meeting to maximize its productivity. The hard part is that this in-the-moment awareness of one's current state is difficult because mentors and mentees are already juggling a lot on their mind. Mentors must process what the mentees are saying, find holes in their logic, and figure out a way to deliver a response that isn't direct in order to make a teaching moment out of it. Mentees must process what the mentors are saying, try to understand their logic, and deliver a response that confirms their understanding or poses a question to help them form their understanding. The final part of the challenge that we need to address is flow. Flow is how mentors and mentees naturally navigate a SIG meeting. SIG meetings can be useful or not depending on whether it is addressing something important to the mentee's work, so flow can be good or bad based on this. Here's an example of good flow. Let's say that there's a mentee in SIG who is getting nervous because there's only 10 minutes left in the meeting, but they haven't talked about their important status update presentation. Although they started off the meeting feeling good because their mentor was giving them a lot of nice information on how to think about the risk that their research plan should address, the student or the mentee decided to interrupt their mentor to bring up the time and the status update. After wrapping up the risk conversation in another minute, they begin to discuss the student's idea for their status update, and the student left SIG feeling much more confident. While the previous example is a case of good flow, there are many factors at play that can affect whether flow is good, and all of these factors can be used to measure flow. In the previous example, emotion, discussion topics, and speech time all affected how that SIG went and can be measured. The student felt more nervous as the mentor spent an increasing amount of time giving feedback on their research plan, eventually causing the student or the mentee to speak up and interrupt the mentor so that they could switch the discussion topic to the student's status update. And with that, we began our quarter to improve SIG meetings through in-the-moment regulation while maintaining flow. You can divide this quarter up into 4 stages as seen here. We first conducted some need finding to complement previous quarter's work, wrote out arguments concerning the challenge and our prototype, made a prototype, and then conducted some user tests to determine if our arguments held up. We had 2 main iterations of our prototype, which we'll be discussing, and is also why you see those arrows between the last 2 stages. As I just mentioned, the first phase of this quarter was dedicated to need finding. Our need-finding observations and interviews were grounded in SIG goals, but then we added flow in to learn more because it was a new concept that we hadn't focused on previously. Ariella and I marked down certain points, such as clarification questions, pauses to check in, and transitions for discussion topics when we observed SIGs, then asked about why those actions came about and how they related to users' goals to learn more about flow in our interviews. After conducting the interviews, we then did some qualitative coding. We went through the transcriptions of our interviews and highlighted quotes. After having many quotes from mentees and many quotes from mentors, we could then find themes in what was said across the multiple interviews we conducted. By combining our new information with the information from previous quarters, we identified the most important outcome and obstacle to center our arguments and prototype around. Regardless of how SIG meetings go, we want a mentor to be aware of when a mentee is confused so that the confusion can be addressed in the moment. What's difficult about this currently is that mentees may not bring up their confusion at all or wait a while to bring it up because they find it awkward interrupting a mentor, think their mentor will answer the questions if they just keep explaining, or believe that the answer lies in their notes or partner so they can clarify it after the fact. Since the current method for communicating confusion is through speech, if it is communicated, we want to design a prototype that makes a mentee's notes visible to the mentor during SIG. That way, the student can immediately show their confusion without explicitly interrupting the mentor's feedback. To realize the outcome of our design arguments, we developed a visible note-taking prototype with 3 components. We had a shared Google Doc where the students could take notes and the mentor could see those notes. Next, we had an alert component to remind mentors if there was any confusion in the document that remained unaddressed. And finally, we also had a lightweight note-taking scheme to know when there was confusion and show where that confusion was within the student's notes. Our interface and system arguments explain why we believe each component would be successful. In order to make their confusion visible to the mentor, students need to be able to realize that they were confused in the first place. Often this happens after SIG when they realize that they don't know how to extrapolate practical next steps from conceptual feedback, so we had students classify feedback as part of the note-taking scheme. We had 2 iterations of the prototype related to this. Students took notes in a 2-column layout in the first iteration, where each column was for one type of feedback. The second iteration had students underline practical feedback while leaving conceptual comments normal. We hope that these note-taking schemes would help provide a visual to see what type of feedback mentees got and prompt them to extrapolate concrete next steps if they had no practical notes. On the flip side of making confusion visible to mentors themselves needed to be able to parse through students' notes quickly because they're already mentally burdened. This could be difficult because a mentor may be unfamiliar with the student's notation style, or there could just be a lot of notes to look through. To address this obstacle, we had students bold any areas of confusion to help draw the mentor's attention to these confusion points. Now, Ariella will continue the presentation and take it away with these system arguments.
We anticipate that it might be difficult for students to categorize feedback because it may be distracting to do so while listening to a mentor's feedback and taking notes. So we provided definitions and examples of each type at the top of the document. We also anticipate that different types of alerts could distract different mentors because some look at the notes document and others do not. So we gave mentors a choice of how they'd like to be alerted once a confusion goes unanswered for 2 minutes. They could either be pinged via Slack or have the confusion highlighted in red to draw more awareness to it. The first prototype we tested had students divide each type of feedback into columns. The issue with this is that some bullet points had practical and conceptual components, and students were either forced to split up a single note into 2 columns, or they just ignored the categorization component altogether. In our second prototype, we allowed students to keep their notes in one space. We asked them to underline practical feedback and leave conceptual feedback as is. This way, they didn't have to split up notes that had different types of feedback. To understand how students and mentors interacted with these prototypes, we tested them during SIG meetings and then interviewed all users to see which components they liked and disliked. We conducted a study across 3 SIG teams with 8 students and 3 mentors. The purpose of this study was to find evidence that supported or broke our arguments such that we could make them stronger. Specifically, we had 4 hypotheses that we wanted to test. The hypotheses state that it will be easy for students to show their confusion in their notes. It will be easy for students to categorize feedback. The prototype does not interrupt the flow of SIG, and it is easy for mentors to be aware of a student's confusion. Our first core finding from the study was that neither students nor mentors liked a 2-column layout. It made it difficult for students to take notes while listening to feedback, so they often miscategorized feedback, and it made it difficult for mentors to quickly parse through a student's notes to check understanding. In terms of our design argument, this does not meet the outcome of mentors being aware of student confusion. The miscategorization of feedback was not a good visualization of what information the mentees received, so mentors did not have an accurate account as to what the students understood. Our second core finding from the study was that well-formulated confusion takes away from one's ability to listen for a longer period of time, but it makes it easier to articulate questions if they do get brought up. In terms of our interface arguments, this does not meet the characteristic of students bolding a section of their notes every time they are confused. The bolding itself wasn't hard, but deciding what to bold and how to phrase it took away time from listening to a mentor and taking other notes. Our next core finding from the study was that the transition to Google Docs as a medium for note taking was easy, as long as the notes did not force a physical structure on students. In terms of our design argument, this supports the characteristic of the student being able to easily write visible notes. Our final core finding from the study was that mentors do not pay attention to notes when other documents are being referenced. In terms of our design argument, this does not meet the characteristic of students writing visible notes so that their confusion can be shown to the mentor. Because students bolding sections does not mean mentors will necessarily be aware of student confusion if they aren't paying attention to a student's notes. A major limitation we faced this quarter was the brief testing period we had for our prototype and our arguments. We didn't start prototyping until the end of the quarter, and we eventually ran out of SIG meetings to test in. We would have liked to see how users adapt to the prototype over time, if there is a learning curve that could have affected results, and if other iterations would have met users' needs better. Although Carol and I are not continuing on this project next quarter, there are a couple things we'd like to continue, had we had the time. First, we would have conducted a longer-term study to be able to see whether our long-term arguments are supported or not. After testing this quarter, we've identified areas of improvement for our prototype. We realize that a two-column layout is bad for mentors and mentees and should be avoided in the future. And the prototype should be better integrated with existing SIG documents. Thank you for watching.